Esta semana en el Colegio Nacional, un radiotelescopio de nueva generación. El Tahuantinsuyo y el Virreinato del Perú. Poesía del barroco novohispano, fiesta y competencia. Los Estados Unidos y el nacimiento de la Edad de Oro de la crítica. Despacio que tengo prisa. La historia de una paleontóloga y Tlatolopus. La evolución de la autonomía universitaria. Del 14 al 19 de junio, el Colegio Nacional te invita.
De este lado, delineado facial.
Esta semana en el Colegio Nacional, un radiotelescopio de nueva generación. El Tahuantinsuyo y el Virreinato del Perú. Poesía del barroco novohispano, fiesta y competencia. Los Estados Unidos y el nacimiento de la Edad de Oro de la crítica. Despacio que tengo prisa. La historia de una paleontóloga y tlatolopus. La evolución de la autonomía universitaria. Del 14 al 19 de junio, el Colegio Nacional te invita.
Te quieres tatuar, te quieres perforar de este lado, delineado facial,
We welcome you to
Le damos la
this
bienvenida
special edition
a
of
esta edición
Noticias del
especial,
Cosmos, which is a joint event
lo
between
cual es
el
un
Colegio Nacional,
del
the
Colegio Nacional,
Mexican Academy,
de la Academia
the Mexican Embassy in the USA,
Embajada
and
de
the
México en
Mexican
Estados
Cultural
Unidos
Institute
y el
in
Instituto
Washington,
Cultural
D.C.
de
We
México en
thank
Washington.
Mr. Piero
Damos las
Sarmiento,
gracias a Piero
who will
Sarmiento,
be our interpreter.
quien va a ser nuestro intérprete.
First, let me
Primero
introduce
que
our
todo,
guest,
permítanme
Dr. Anthony
presentar a
J.
nuestro
Beasley,
invitado,
who
el
will
doctor
talk
Tony
about a
Ortiz,
new generation radio
para
telescope.
hablar acerca de la
Dr. Anthony
generación de
Beasley
radio
became director of the
que se
National
convirtió
Radio
en el
Astronomy
director
Observatory
del
NRAO in
Observatorio
2012.
Astrónomo
He
desde
serves as
2012.
Vice President
Ha servido
of
como
NRAO at
vicepresidente
the
de
Associated
NRO
Universities Incorporated.
en las universidades
He
asociadas
received his
incorporadas.
bachelor's
Él
degree in
recibió
physics
su
with
bachiller
first class honors in
de primera clase de
1986
honores
and
en
a PhD in astrophysics in
1989,
1991 from the University
el
of Sydney,
doctorado
Australia.
de Sydney,
His
Australia, en
doctoral thesis
1991.
examined magnetic field generation and
Examinó
solar
la
stellar
generación
activity in
magnética y la
post-supernova
actividad
stars.
solar
His
y las
scientific
actividades
interests include
estelares.
non-thermal stellar radio emission,
Su
very long baseline
enfoque
interferometric
incluye
techniques,
la
radio supernova, and astrometry of stellar
supernova,
interstellar masers. He first joined NRAO as a postdoc Then as a
como
scientific
grado
staff
y
member
después
and
como
senior manager in
miembro
New Mexico and
científico
Charlottesville, Virginia.
Carlos Virginia.
Since 2000, his
Desde
career has
su
focused on the
carrera se
design,
ha centrado
construction,
en el diseño,
operation, and
construcción, la
management
operación y el
of
manejo
major scientific
de
research facilities,
muchas
with
facilidades
roles
locales de
including
investigación
project manager from the combined array for
que involucran
research
con
in millimeter wave
el
astronomy,
manejo
CADA,
de
from
proyectos
2000 to 2004.
del 2000
He
a
was ALMA
2004.
project manager at the
Fue
Joint ALMA
el gerente
Observatory in
principal
Chile from
del
2004
observador
to
ALMA
2008,
de Chile desde
leading the
2004
ALMA
al
construction
2008,
project through multiple
liderando
international
el proyecto de
reviews and
construcción.
major rebaselining effort. He was also
También
operations officer and
fue
project manager for the
cooperador
National
de
Ecological
operaciones,
Observatory Network, NEON,
gerente
from
de
2008 to 2012,
desde
leading this
2008 a
continental
2012,
scale observatory designed to provide scientists with
ayudando
30
a
years
proveer a
of
los
ecological data on the impacts of
científicos,
climate change,
dándole data
land use
de
change, and
eh,
invasive
los
species of
cambios,
natural resources and biodiversity.
cambios climáticos y
Dr.
también los
Luis
cambios
Felipe
de las
Rodríguez and
naturales
myself,
con
Susana
respecto.
Lizano, are members of El Colegio Nacional.
Todos somos partes
We
del
are
Colegio
both
Nacional,
astronomers and work at the
ambos somos
Institute
astrónomos,
of Radioastronomy and Astrophysics
trabajamos en
at
el
the
Instituto
National
de
University of Mexico in Morelia,
la
Michoacán.
Universidad
Dr.
Nacional de
Rodriguez is a
México.
distinguished observer that started
Rodríguez
the
es
field of radioastronomy in Mexico.
distinguido
I
en
work
el
in models
equipo
of
de
the physical
astronomía.
processes that occur during the formation of
También
stars in our galaxy.
se encarga
We are really
de
happy to have you here,
estudiar las formaciones de las
Dr.
galaxias.
Beasley, and if you would please start your talk.
Gracias por estar con nosotros, doctor.
Okay.
El doctor Beasley, por favor, comience con la charla.
Okay, well, good afternoon or good evening.
Tardes.
My name is Tony Beasley. I'd like to
Doctor
thank
Beasley.
El Colegio
Ya
Nacional for inviting me to give this talk today.
a Susana
What I
Lizano
will be talking about
de hoy
is the next generation very large array.
de la
This is
diferente
a project to
generación
build a
de la
large
gran
new
gama,
radio telescope in the
lo
desert
cual se
southwest
enfoca
of
en
the
el
United States.
radiotelescopio en
And this
el
is a project that we are
suroeste de
working
los
on
Estados
with
Unidos, un
our
proyecto que
international
estamos
partners,
trabajando,
including our colleagues from Mexico.
involucrando a todos nuestros colegas de Nuevo México.
So the Jansky Very Large Array is a radio telescope
La más grande es un
Mexico.
radiotelescopio en
It was
Nuevo
built in the
México, fue
1970s
construido en
and through
1970,
1980s and
en
1990s did
los
a
80,
lot of amazing science.
1990, hemos hecho
There
mucha
was an
ciencia
upgrade of the telescope in the 2000s.
operado
We
como un
improved it somewhat.
telescopio en el
But this
2000
has been
y
a
ahora
fantastic collaboration between
entonces
US and
tiene una nueva
Mexico. A lot of that
colaboración
is
entre México y
owed to
Estados
Luis
Unidos.
Rodriguez, who has really been an incredible
Le
supporter
damos
of
el favor
the
al señor Luis
over the years.
Rodríguez.
In 1994,
En
with support from our Mexican
1994
colleagues, we
apoyó
produced 7
de
millimeter radio receivers for the
nuestros
VLA.
colegas de
Mexico was
México.
also part of the
México
support for
también
the
fue
upgrade of the VLA
gran
to becoming the
apoyo
Jansky Very Large Array. And then
con
later
la
on in 2011, our Mexican
2011.
colleagues also took
Nuestros
part
colegas
in
también
support for the Very Long Baseline Array.
parte
So we have, 2 or 3
poner
decades of
y
working together in radio astronomy
establecer
on
toda
this
esta
instrument.
radiotelescopio.
So we have a plan, and
Tenemos
that
un
plan
plan.
is to build a
Vamos
next
a
generation
construir
very
una
large array.
nueva generación
The
de
current
gamas.
VLA is still very, very scientifically
El
appealing and
nuevo arreglo, la
capable,
nueva
but there are
generación
frontiers to be reached.
eh,
And one in
ha
particular is
avanzado, pero hay
imaging the
fronteras
sky
que tenemos que
on
alcanzar.
milliarc-second scales, looking at the thermal radio emission. And I'll explain a bit more about that later. Sort of pragmatically, the goal is to increase the sensitivity and the resolution of the VLA by
La sensibilidad y la
an order of
resolución
magnitude.
del
We
arreglo
want
de
to increase the frequency range covered by the telescope
dar
from
el rango de
1.2
frecuencia
gigahertz, which is about the radio frequency of your cell phone, up to 116 gigahertz.
hasta
So
116.
times higher.
Screen?
¿Quiere compartir su pantalla?
Is it not shared?
No.
¿Está compartido? No.
Well, I don't see it.
No la veo, por lo menos de mi parte.
Let's try again.
Déjame intentar de nuevo.
Yes, sorry.
Share. There you go. Sorry, I thought I was sharing.
Disculpa, Cristian, que ya estaba
Now it's
compartiendo.
perfect.
Okay, so shift F5. So this is a sort of a simulation of the NGVLA.
De cómo van a
So
ser
there are
las
multiple parts to the NGVLA. There is a
partes
short
de
baseline
Gran
array.
Arreglo de
We
Nueva
have a
Generación.
collection of small antennas.
Una
They're
colección de
all
bastantes
on
antenas
scales of a few hundred meters.
que tiene una
The
escala de
antennas
un
you
par de
see in the middle
kilómetros.
of the diagram here.
Ahí
There's the main array, and this is where
tenemos
we really get out to this
el Gran
what's
Arreglo
of
de Nueva
interest. You
Generación
see the
principal.
if you focus on the bottom right-hand corner here,
Concentra
you
aquí
see
en la
sort
esquina
of
a la derecha.
components of the array.
Se va a dar
Then
cuenta
expands out into this
diferentes
5-ohm
patrones
spiral of
que se
antennas,
expanden en este
and then actually
espiral
out into this very
y
large distribution,
eventualmente se
which
convierte en
in
esta
turn
distribución grande,
includes antennas
lo
in
cual
Mexico.
involucra
So
antenas.
this is part of the concept of the
Es parte del
NGVLA, is to
concepto
produce an
que
instrument
estamos
that
trabajando
actually operates on a
en
much larger physical
que
scale
trabaja
by
en una
placing
escala
antennas
más
much
grande,
further away
teniendo
further
antenas
away than
mucho
we
más
would like to
largas
do. On longer
desplazadas por
scales, we even include an instrument
en
that
una de
we
las
run at the moment
escalas.
called the
Nosotros
very
también
long baseline array.
logramos,
And so you see here again, the blue dot is the
como ver
location
aquí,
of the
el
array.
punto
The
azul,
pink circles are meant
los
to
puntos
represent the
rosados representan
additional stations that we want to build,
estaciones
including
adicionales que
stations in
queremos
Mexico.
construir en
And then
México.
ultimately, we
Y
include
también
the very long baseline array antennas.
involucraríamos estaciones
So by producing this, we're producing an instrument which really spans all of North America.
expandiendo
We have instruments in
ambas,
the US and in Canada,
ambos
and
países, en
Mexico,
Canadá, en
it's
Estados
in Croy in
Unidos,
the Virgin Islands,
México,
and
en
eventually also out, of course, on Hawaii.
y también en Hawái.
So this is a simulation of the
La
telescope.
simulación, el
This
radiotelescopio,
is to give a sense of what we're
para darnos
talking about.
una idea de lo que
And so
estamos
you see
hablando.
in the foreground
Como
here
pueden ver ahí,
the short baseline antennas
las
observing,
antenas que
and then
están
as you sort of
en
pull
las
out, you see
orillas
the larger antennas
y las
surrounding them.
que
These
están
are
rellenas
offset
más grandes,
antennas, offset Gregorian antennas. They're not symmetric like the current VLA antennas.
métricas.
So we, in the simulation here, we fly
Simulación.
around the site and we look at some of the values
Viajamos
that
alrededor del
are on
lago,
the site here.
revisarlo,
And then we start to pull back and see the scale of the instrument.
comenzamos a
So
ver
in the image that we're looking at here, there are approximately 100 antennas.
hay alrededor de
Scale,
100
that's about
antenas,
190 antennas. And
190 en
ultimately, you
total.
pull back again, you see the
Va más
antennas
atrás,
in northern Mexico,
de las
and
antenas
the antennas
en
on
el norte
the
de
longer
México
baselines.
y en otras partes más lejanas.
So what's the type of science we want to do with
¿Cuál es la
NGVLA?
ciencia que queremos hacer en Gran?
Here are 5 what we call key science goals.
Hay
And these
5
are
claves.
things of great interest to the astronomy community, of great interest to
Estamos muy
science.
enfocadas y
So
le
one
damos
is
el
to unveil the formation of solar system analogs on
y poder
terrestrial
entender
scale.
más la
So this is
formación de
really just looking at
las
the formation of
analogías y las
planets
escalas
on
terrestriales.
scales in the solar system, kind of the same
Las
distance
escalas
from our sun
queremos,
that the Earth is.
queremos entender
We can
todas
also
las
look at the
distancias y las escalas.
conditions of planetary life, looking at the
Tenemos,
chemistry
queremos
of solar material, so that's called astrochemistry.
tomar muestras
The
y
assembly, structure, and
ver
evolution of
las condiciones
galaxies over
iniciales de
over
sistemas
time.
planetarios y
That's
la vida
another
y
great
la
project looking at
química.
molecular gas and dust in the
Entender
distant universe.
mejor cómo
We can
funciona
look at
el
pulsars. In
polvo, el
particular, we can
gas,
look at pulsars at the center of the galaxy.
poder
We
ver
believe
el
at the center of our galaxy there's a very massive black hole.
centro de la
Massive black
galaxia
hole.
tiene
And
mucho
by
gas,
looking at the way that stars and gas and material are distributed around that black
y
hole,
cómo
we
el
can learn a lot
material
about gravity.
está
And we can learn a lot about
distribuido, podemos
the
aprender mucho acerca de la gravedad.
And then the last one is
La última
continuing a
parte es
journey that we've been doing with our telescopes
continuar,
for many years, many decades.
continuar
Is really
nuestro
looking at the way
viaje
that black holes
para entender más
in
la
the center of our
formación
galaxy and in the stars near
de
the
las
Earth
estrellas,
and other
de la
galaxies
galaxia,
affect the environment.
y ver cómo
We
esto
see
afecta al medio
jets and we
ambiente.
see all kinds of explosive phenomena arising from these black holes, and by
Desde
studying them
nosotros
in
vemos
detail
muchos
and high
fenómenos
resolution, we can learn
científicos
more.
que salen a la luz
So this is
debido
a
al
good example of the type of observation that NGVLA will be able to make. So what we're looking at here is really the formation of
la
planets
formación de los
from a
planetas,
disk of gas and dust
de un
around,
disco
basically
de
forming around a
gas y de
nearby star.
polvo que se está
So
formando.
these stars are young.
Ese
These are
es
stars that are perhaps a few million years old or something like that.
un par de
But
miles
again,
de
what
años.
we can do with our telescopes like ALMA and
Telescopios
some of the
como los que
optical
tenemos,
telescopes is we can kind of look at the whole solar system
podemos
inside.
ver todo el
But until we
sistema
build the NGVLA, we will not be able to get down
en el
on
gran
these
arreglo
sorts
de
of
la nueva
scales where you
generación,
actually start to see planets
de poder
like
conocer
Jupiter and Neptune and Saturn and ultimately perhaps the Earth in here.
y hasta la Tierra.
You can actually look at their formation. You can
Podemos
see
ver la
the gas
formación
and the dust being
y el
sucked
polvo
gravitationally into a planet.
succionados
And then the other
gravitacionalmente.
thing we can do, which I'll show a bit more in a moment,
Lo
is that
vemos
we
en un
can measure
ratito,
the
que
chemistry of
podemos
these
medir
planets.
la
We
química,
can actually look at the atoms and molecules that are making up these
átomos y las
planets.
moléculas
And
que
so
están
what you can
siendo
learn from
construidos.
that is
Lo que
both how
puedes
these
aprender
planets
de
are
esto,
forming, but
cómo
you
se
also
están
then
formando los
become aware
planetas,
of what are the
pero
initial
también nos podemos
building blocks for
percatar
life on these
cuáles
planets.
son los
And so
bloques,
if you were to look at some of these planets and you were to see a lot of organic materials and a
podemos
lot of
entender
water,
los
for
materiales
example, well,
orgánicos,
then you might understand that these planets are
agua,
forming and they might be
agua,
covered in oceans.
o
And those
si están
oceans are
cubiertos de
filled with
océano,
organic material. They're filled
cuáles
with
tienen
carbon,
material
showing
orgánico,
chemistry that might ultimately evolve into some kind of life form. And so that's
eventualmente
a big
pueden
part of what we're trying to do here, is we're trying to
formar.
really understand the way that
Queremos
planets like the Earth
queremos
form around
entender
stars, and then what are
cómo
the
los planetas
components,
como la
the
Tierra
elements and
pueden
the atoms
formar
and
las
molecules and so
estrellas
on
y
that
las
form
moléculas
into those planets,
de
but
ese
then possibly eventually can produce
planeta
life
y
forms.
eventualmente producir.
This is an example of what
Es un
looking
ejemplo
for
de
life looks like in a
cómo
lot of
el
these situations.
tipo de
So
vida
this
que
is just a
vemos.
section of spectrum.
Esa es una
So this is kind
sección
of like, you know, if you turn the FM dial on your car, if you go from the bottom to the top, as you do that, sometimes you'll find a radio station or you'll find a distant radio station, which is leaving.
es una
So
estación
that's exactly what we're doing here, and that's something we can do with the telescope.
podemos hacer con
We
el
can actually look
telescopio.
at different parts of the radio spectrum.
Partes
This
del
is like
espectro
24 gigahertz up through 28 gigahertz. And what we will detect
vamos a
are
detectar
the radio emissions which are given
las
off by
emisiones
these
de rayos
organic
que
molecules.
emiten por
And
estas
so when we
moléculas
look out in space today,
que vemos en el
obviously
espacio el
looking
día
at with
de
the
hoy,
NGVLA, but when we look out with telescopes like the VLA or
vemos
the
con
Green
el
Beam
telescopio
telescopes or ALMA,
de nueva
what we see
generación,
is we see
vemos
very specific radio emission
muy
coming from these
específicas
molecules.
emisiones
And so
de
what you can see here is an example of a few of the types of
moléculas.
molecules we're
Lo que
seeing.
podemos ver aquí
So as I said, I think there's about 2,000 or 3,000 molecules that have been discovered in space. And these are molecules we see here on Earth. It's like sugar and water and alcohol and these types of things. We haven't yet discovered some of the building blocks of DNA in space, but people are looking for that. And so this is, again, this is astrochemistry, looking at prebiotic molecules and trying to understand the initial conditions in these forming planets. We can look at the gas and the dust.
podemos ver al gas y el
Eventually, there are
polvo,
these large, giant molecular clouds that are
que
filled
son
with
estas
molecular gas
grandes
and dust.
nubes
Gravity
moleculares.
collapses them and they become
La
stars.
gravedad se
And around
colapsa y
those
se
stars,
comienza,
disks
se
form, and
convierten en
from those
estrellas.
disks, planets are formed. So by looking at some of these galaxies, looking at nearby
Donde
galaxies
vemos
and
las
actually looking at
galaxias
galaxies in
y
the
si ves
distant
en las
universe as
galaxias de
well, we
distancia,
can see the
podemos
formation
ver
of
la
stars, and we
formación de
can
las
learn a lot
estrellas.
about what are the different types of stars that can
Puedes
be
ver los
formed.
diferentes tipos de
And you know,
estrellas
increasingly
que
we
están
have theories about
formando.
what are the types of planets that can
Con el
form
pasar del
against them.
tiempo tenemos
So
mejor
this is a
una
very hot
teoría
area of research.
completa
This
de
is
cómo se
something of
forman los
great interest.
planetas.
To really do this well, you need a
De
lot of
manera,
sensitivity, a lot of resolution. And that's
tenemos
hopefully
más
that
sensibilidad,
protection from
mejor
the
resolución.
NGVLA. And then I mentioned earlier, we've spent
Está
many years,
hablando
many
más
decades
antes
actually,
que pasamos muchos
looking
años
at
y décadas
the impact of
inclusive,
black
hablando
holes.
acerca
So,
del
you know, we
impacto
find
de
black
los
holes
agujeros
on stellar
oscuros.
scales. We find black holes that are a
Los,
few times the
hemos
mass of our
visto
sun. We
agujeros
find
oscuros
black
que
holes which are hundreds or thousands of times the mass of
100
our
o
sun.
1000 veces
And we
más el
find black
tamaño
holes in nearby
de
galaxies which are perhaps billions of times the mass of
y,
our sun. And in
y
each of
también
these
hemos encontrado
cases, we
agujeros
see the
oscuros que
same kind
son
of phenomena. We
billones de veces
see
más grandes.
very energetic events. We see interesting spectrum.
Siempre
Things like
ocurren
electromagnetic
espectros bien
band. We
interesantes,
see jets and
actividades muy
activity. We see great
energéticas,
explosions and so on. And we really
explosiones,
don't
cosas por el
understand a
estilo,
lot
y
of
no
that. You
entendemos
know, we
todavía
understand some of the
todo
basic
esto al
physics, but a
100%.
lot of the detailed theory is
Muchas de
not
las
known yet. And so by using the NGVLA, using our existing telescopes and moving into the NGVLA, we are studying samples of these objects and
de
really
esta manera
trying to
estamos
understand
entendiendo
how these black holes accrete
y
the
cómo estos
material
agujeros oscuros
around
han
them,
sido
how they
creados,
produce these jets of emission that we see in
a ver
galaxies and
cómo
in stars,
producen estas
and just in
emisiones
general,
de
how
jet
they impact their environment.
y cómo
Over the
impacta
last
el medio
5
ambiente.
years, we've
En los
seen
últimos 5
3 or
años
4
hemos
5
visto
years, we've seen gravitational wave discoveries.
Hemos visto descubrimientos de ondas de
And there's a lot about
gravedad.
that we don't understand.
Y hay muchas cosas que no entendemos al respecto.
And using the NGVLA in the future, we are going to be able to detect many of the precursor objects and look at what happens when these type of
Si usamos el gran arreglo de nueva generación, vamos a tener un mejor entendimiento de qué es lo que está
in terms of
sucediendo,
technology, one thing that
cómo
was
está
required for the
sucediendo.
NGVLA was
En
a new
aspecto
type
de
of
la
antenna.
tecnología,
We have very good antennas
tenemos
for the
antenas
VLA,
muy
but
buenas
also excellent
para el
antennas
gran
for
arreglo de
power.
nueva
We
generación.
needed something that was
Tenemos
large
algo
and
que
kind
sea
of mimicking
grande
the properties of those two different antennas.
y
So
que
over the last couple of years,
sea lo
we've been
mejor
through a
de las
design
propiedades,
development
lo mejor de las
process
propiedades de las
where
antenas.
we've worked with companies to look at designs of the antenna. And
Hemos
this is
trabajado
actually
con
the
varias
selected
compañías
design. We
para
made
que
this
en
decision a few
el
weeks
caso de las
ago.
señales,
This
el
is
poder de
a company in
la
Germany called MTEX.
Hay
They have
una
designed the
compañía en
antenna,
Alemania que se llama
and in the next few years, next 2 to
los
3 years, the
últimos
National
2 o
Science
3 años,
Foundation, we are talking to them about
con
building
la
a
Fundación
prototype antenna, or a single one
estamos
of these
hablando
antennas
estamos
at the
charlando a
VLA
ver si la
site,
posibilidad de que
basically.
puedan hacer una antena
I'm actually hopeful to be announcing that project, and the start of that project
tengo
will be
esperanza de
sometime in the next
poder
few
comenzar
months.
este
That's a
proyecto
very,
en
very
los próximos
exciting step
meses.
forward. These antennas
Las
look like
antenas
this. You know,
se
this
ven de
is
esta
an
manera,
artist's rendering of them. You know, what you actually
¿no?
see
Aquí
here is
desplazadas de
the
esta
main
manera.
reflecting.
Lo que
The
puede haber
light
ahí
energy
es
comes down from the sky, bounces off
las
the main
ondas se
reflector,
deflectan de
bounces off a
ahí
subreflector that is on
y
the other
salen
side of this
por el
object,
reflector de
and then
ahí
there's a receiving element
y hay un
above.
elemento
So
recibidor.
these antennas are
Las
different to our
antenas son
existing antenna.
diferentes a
They're
las
lighter
diferentes
and they're more
antenas,
capable in many
son
ways, and that's
más
just the
leves.
advantage of, you know, essentially 50 years of technology.
Ese es un
Carbon
avance de
fiber
50
technology and
años de
other sorts of
tecnología
advances that
enfocada en
enable us to
desarrollar este
build
tipo de
those
antenas.
types of antennas. So in terms of project timeline,
Eh,
we're kind of about here
Ahora
at the
acerca de
moment,
la agenda, en la
2021.
línea del
So
tiempo,
the
la
astronomy
producción de este tipo
decadal
de
survey, the
antenas,
US decadal survey process is underway. We hope the report for
tenemos
that will
el
come out
reporte
sometime
para
in the next
esto que ya va a
month
salir
or
en los
few.
próximos
And when
meses.
that comes out, that's
Cuando
kind of
salga a
the
la luz
marching
este
orders for the
reporte,
US community to get along and start
y
thinking
vamos a
about
tener que
constructing one of
trabajar
these
con
things.
la comunidad aquí en Estados
Assuming a
Unidos
good
para poder
recommendation in
tomar
the
la
decadal
iniciativa de
survey,
construirlo
we will
por
be delivering the
las
prototype to
zonas
the site and
en
beginning
las que habíamos
our serious
señalado al
testing of the
comienzo.
antenna.
Vamos a
We will
hacer
submit a
evaluaciones
proposal to the
iniciales
National
de las
Science
antenas
Foundation for
con,
NGVLA
con
construction.
la Fundación de
If we
Ciencias
get to
en el
2024 and
2023,
2025,
2024,
and the project is in
2025,
good shape,
ya
and
cuando el
the
proyecto debería
NSF
estar
is
en buena
interested in
forma.
moving forward into
Vamos
construction,
a
we will
ya
start construction
comenzar la
sometime in
construcción en el
2025, let's say
2025
2025, 2026.
o 2026.
We believe that within a
Creemos
few
que
years, just a few years,
en unos
2 or 3
años,
years,
de
we
3
will
años,
have built enough of
ya
NGVLA that we will essentially
habríamos haber
have the existing
construido
collecting area of the
suficientes
current VLA. And that is the
arreglos de la
point
nueva
where we will
generación,
probably begin some of the early science studies with NGVLA.
con lo
Get
cual ya
familiar with the
podríamos
goal
comenzar
and start to
estudios
really shake
científicos
out the
iniciales
instrument. And then
con los
ultimately,
instrumentos
the goal is to
necesarios.
finish construction
Pero
in
la
about 9
meta,
years,
más
so
que
we can
todo,
go
es
to
terminar la
full
construcción de
science
todas estas
operations in
antenas en los últimos 9 años.
2024. So that's the schedule now, and
Desde el
schedules
horario, por ahora,
are very important
es
in the US
importante
community with respect to the decadal
aquí
survey.
en la comunidad de los Estados
And
Unidos,
I've been
especialmente
very
para la gente
pleased
que está
over the last couple of
observando
years that we've been able
la
to
formación de
largely hold this
la
schedule
estrella,
and move forward.
y esperamos
We have
poder
many
continuar,
partners. We have a lot of partners
aferrarnos
in the
a esta
US
agenda
academic community.
y a la
We
línea de
also have
tiempo.
some international partners over here, and of
Tenemos
course our
muchos,
Mexican colleagues are there. We also have commercial partners.
tenemos también
We have companies that are working with us
tenemos
in
personas con las
terms
que
of
están
developing the
trabajando juntos en
technologies that
esto,
are
universidades
required for
locales,
NGVLA.
también
And this is, you know, this is not all
compañeros
of them actually. I mean, we have a lot of people that are
internacionales,
actually engaged in this project.
pues,
It is a
otros
large
muchos
project, a very
diferentes
large project on even on US scales. And so, you know, we have a lot of people that are involved in helping us make the right decisions about the science and the technology. So between the domestic partners here and our corporate and international partners, we've made incredible progress in the project over the last few years. We've had a lot of great science meetings. One of the things that has been fantastic about these meetings is it's, you know, not the existing, later career radio astronomers that we see here. There's a lot of new young faces here. This is a very diverse crowd, and these are people that are really looking to, you know, radio astronomy and NGVLA as an incredible path forward in their careers, in their research careers. We've had an international conference. This was our first international science conference in Japan in 2019, and I'm actually hoping that we can do something like this in Mexico sometime in the next year or two. That would be a fantastic way to introduce the facility to the science community. Okay, so I mentioned at the start of the talk that there's a long history between US and Mexican radio astronomy. As the US reviews, the Decadal Survey reviews NGVLA, and we are seeing strong support from the National Science Foundation, what I would like to do is build on this long tradition of US-Mexico collaboration in radio astronomy. A lot of the science that I've talked about here, there's a large science book that describes all of the science of NGVLA. A lot of that is incredibly relevant to many of the strong science themes that are being followed in Mexico. In particular, this addition of baselines, antennas into northern Mexico, is really quite critical to the great science of NGVLA. And so, that's why we've done that. That's why we are working with our Mexican colleagues on this. There's really a terrific opportunity there for Mexico to take a significant role in supporting and producing some of the best science from NGVLA. There's also, the possibility that eventually the large millimeter telescope could actually take place, could actually contribute as well. So there are many opportunities here. I think there's a great science and technology development opportunity, getting Mexican scientists and Mexican industry involved in the development of NGVLA. And then there's also, the opportunity to get involved in manufacturing roles. There's a lot of material that needs to be developed for the array. And, we hope there are opportunities there for our colleagues. We had a lovely letter from CONACYT in 2018 supporting some of the early collaboration on NGVLA. So I just kind of put it out there. There are a lot of fantastic opportunities for participation and collaboration here at many different levels. And so I think that's something we certainly need to look at. This is kind of the current configuration, where, as I said, there's a few antennas in northern Mexico here, and possibly eventually some input from the LMT. But this is just an initial plan. I mean, there's lots of different ways that we can line the array out, and I think there's really a dial here that can be turned with our colleagues in Mexico in terms of engagement and participation in NGVLA. So just to finish up, in summary, the NGVLA is a major international project for this decade. We're hoping to really get started on that prototype antenna within a few months, and hopefully construction within a few years. We have these prototyping and research efforts underway. Really, there's a great opportunity here for everyone involved in NGVLA in terms of the scientific return, the engineering that's developed, and really associated with the science that we do and the creation of the array. There are incredible STEM opportunities in all of the countries. A big part of what we want to do here is really engage with students of all ages, K through 12, K through grade, to really get them, informed and excited, and to really understand the project as we sort of unroll it over the next decade. And so, just to finish up, Mexico has been one of the founding countries of NGVLA. Luis and Laurent and others have been at our early meetings. And so we really hope there's more scientific and project participation possible in future, and I would greatly welcome it. Thank you.
Thank you, Tony, for this very interesting talk. I hope that Mexico will get involved in this wonderful project. Now I am going to talk briefly about research topics that the community of Mexican astronomers are interested in studying, with the amazing capabilities of the next generation VLA. So let me share my screen. Please tell me if you can see my screen.
Yes.
Yes. Okay. Let me put it in. Thank you. So the topics that the Mexican astronomers are mostly involved in have to do with the formation of stars and planets. I'm going to repeat some of the things that Dr. Beasley just mention. But first, let me tell you that our galaxy is similar to the Andromeda galaxy. Here is an image of Andromeda galaxy, which is a disk galaxy that has a bulge of stars in the center. And in the case of our galaxy, it has a supermassive black hole in the center with 4 million solar masses. And it has a disk of gas and stars that goes around the center of the galaxy. This gas in the plane in the galactic plane is in the form of clouds, which are very cold, and they are in molecular form, so they are called molecular clouds. And the molecular clouds have very whimsical shapes. For example, I'm showing you here. This is the Cone Nebula, and down here is the Fox Nebula, and on the right you can see the Orion Nebula, which is in the constellation of Orion along the sword of Orion. So inside these cold clouds, new stars are formed, and when the new star is formed, it always forms a disk around the young star, a disk of gas and dust, and also the star very early on turns on a collimated wind, very powerful wind, that in this image you can see as two lobes ejected in the perpendicular direction to the disk. And on the right you can see that there's evidence of rotation of the disk and also of motion of the wind perpendicular to the disk. And these winds are going to help destroy the natal cloud. So as Dr. Beasley mentioned, here you see an image obtained with the interferometer ALMA in the Atacama Desert in Chile, and you can see some gaps that could show the early formation of young planets. The problem is that currently all the available facilities cannot observe the inner region, that is the place where terrestrial planets should be forming. Either they don't have the resolution to observe the region, or the regions are opaque to the wavelengths at which they are observed are opaque to the emission, so that it's not possible to know what's going on in the center of the protoplanetary disks. And this is what we want to understand, and many astronomers in Mexico are working on these types of problems. Also, massive stars are also born in our galaxy, and when they start shining, they are very hot and luminous, so they ionize the cloud around, and they also have very strong winds. So here on the right you see a sketch of a stellar wind and also the ionized region, and this wind pushes around the molecular cloud, and actually it's the funny shapes and the beautiful shapes of the molecular clouds are due to the interaction with the radiation and the winds of these young stars. So here I show you on the left the Trifid Nebula, which is observed in the optical wavelengths, and in the middle panel it's observed in infrared wavelengths. They are also observed in radio wavelengths, and in particular the NGBLA will be able to study this ionized and hot gas in our galaxy, but also in external galaxies with very high angular resolution. So another topic that is worked in Mexico is the study not only of the hot gas, but also of the cold molecular gas and the dust that is the material necessary to form new stars. So here you can see an image of the galactic plane, and you see the emission of this cold gas and dust obtained with the Apex telescope, also in Chile, and at 870 microns. But this type of studies can be carried on by the NGBLA with a much higher granular resolution, and the study of the ionized and the neutral gas will give information about the process of star formation in galaxies across the cosmic time. And finally, another type of studies that are of interest of the Mexican community have to do with the interaction of the stellar winds and the supernova explosions, and even the black holes in the supermassive black holes in the center of the galaxies that create these winds interact with the galaxy, and they create what is called galactic fountains, which is material that blows away from the center and from different parts of for example, in this case, this is the plane of our galaxy, and you can see the hot bubbles of gas in X-rays. And these galactic fountains recycle the gas from the galactic plane, and then it blows away and then comes back to the disk. And it also can enrich with metals the intergalactic medium. And on the right, you see a galactic fountain from an elliptical galaxy. So these are the type of problems that the Mexican community, the radio astronomers and the theoreticians are working on. And we think that using the NGVLA will improve tremendously on all these studies, and will really have an impact on our understanding of the formation of stars, not only in our galaxy, but across the life of the universe, to see very early galaxies. Thank you. So I think now Dr. Luis Rodriguez I will stop share. So can please.
Thank you very much, Susana, and thank you, Tony, for both. You gave an excellent talks that introduced this topic to, I hope, many U.S. and many Mexican people. I just wanted to say a few words of astronomy and international collaboration. It turns out to be that we astronomers are pioneers in the idea that countries, instead of fighting each other, should get together towards a common goal. Since 1919, more than 100 years ago, astronomers created the International Astronomy Union. This is a very important union of astronomers that has all the countries in the world and organizes meetings, organizes events, documents, teachings that are produced by everybody in the world. And the Next Generation BLA, it is a project of that sort. It is something that would be very beneficial, of course, for the US and Mexico, but also for the other countries that are interested in participating. This idea of doing things among many countries is very interesting. It's not that tremendously old. The idea is that, as I said, let's say in the middle of the last century, it was more like a confrontation between countries. One country telling the other, I'm better than you, and I don't want to know anything about you. Now this, fortunately, has changed, and countries get together and do projects together. And we have many examples of this. The Next Generation BLA will be very important, but we already have been able to conclude things like the Atacama Large Millimeter Array, where many countries contributed, and there is also ongoing another major project, the Square Kilometer Array, where the instruments are going to be in Australia and South Africa, but many countries are contributing. Now, of course, this in part has been imposed by the economic reality. These projects are so big, so expensive, that it will be hard, even for a country like the US, which is such an economic power, will be hard to do them. And actually our, administrators do ask you to collaborate with other countries because the price is high and it is better that if it is distributed among many countries. Now, the good thing is that in these collaborations, we can benefit a lot. In particular, countries like Mexico that are, let's say, developing could get a lot in terms of science, in terms of technology. Parts of the instruments could be built by Mexican industry, and that would be fantastic for everybody. And I think that this is something that we have to keep pursuing, these international collaborations, and I think that would be the way to go now for anything important in the world. Things are just so big now that we have to be together as countries and collaborate. The price, and maybe Tony would like to say something, is that these are projects that are harder to do. A small project for a country is sort of easier to do. But when you have many countries together, you have to put together different points of view, different cultures, different ways to looking at things. And this requires a lot of patience from the people in charge. That was, for example, the case of the Atacama Large Millimeter Array, ALMA, that is working so wonderfully, changing things. And it had to deal a lot with the idiosyncrasies of the many countries involved, but this was solved successfully. And we're sure that this is going to be the same with the next generation BLA. And I really look forward to start really seeing the building of antennas, the building of receivers, and in particular, seeing these components of the next generation BLA being located in Mexico, in the north of Mexico. One last thing that I will say is that at the point Tony and a group of us visited CONACYT, and one of the concerns of the CONACYT administrators was, they said, well, you know, the north of Mexico is not very safe. But one has to look at this from a different point of view. One of the ways of making the north of Mexico safe is putting science, putting technology there, creating good jobs. All this is going to change things. Many countries, in particular the US, have as a goal to locate these important new accelerators, telescopes in their poorest areas, in the areas that are less populated, because they will bring there good jobs, positions, people, education, science. And we have to start looking at things like that and not being afraid to build scientific instruments in the north of Mexico. So I really look forward to this great opportunity, and I'm sure that Mexico would play a role in this outstanding new project. Thank you very much, Susana.
Thank you, Luis. I also, I spoke about the interest of the Mexican astronomers in the NGBLA, but of course one has to consider what Luis is saying, that is also the development, the economical, technological, and scientific development of the country that is important, not only the science that we do, but that the science reach the people, especially in these areas where Mexico still has many problems to solve. So I don't know if maybe we can take some questions from the people who are listening to us. And I think
well, there are some questions. One question that I see here is that it says, we read in the newspapers about the other similar instruments like ALMA or the SKA, and the question is, do these things overlap, or isn't that a little repetitive? He says, I think that Tony would be the best person to answer.
Sure. So, what you find is, if you look at the scientific capabilities of these different instruments like ALMA and SKA and NGBLA, what we're all trying to do is to produce new capabilities in new parts of the radio spectrum and on new angular scales. So I don't have the diagram in this slide deck, but I can actually show you that SKA at lower frequencies is a very capable, powerful instrument. At higher frequencies, ALMA is unsurpassed and is an incredible instrument. And really, NGVLA is looking to fill that piece of the spectrum between SKA and ALMA. And so, you know, one thing we are very keen on in the US is this open skies approach, where everyone has access to the facilities. And so by doing that, I think if you combine SKA and NGVLA and ALMA, you've got angular, you know, all the angular scales and all the frequencies you need to do all of the research you might be interested in doing in the radio.
Right. Thank you. It is, in some sense, like the gravitational waves that not LEGO is not going to be able to do everything,
right.
And they are planning these very different ideas. One of those is actually part of the NGVLA, actually measuring the timing of the pulsars to really see if we get the passage of a long, very long wavelength gravitational wave. Susana, do you want to add anything?
Yes, no, I think I don't have anything to add. I take the opportunity to ask something to the radio astronomers, both of you. There's some threat by the internet facilities in the Earth that are sending these constellations of satellites on orbit, where they are taking over the radio spectrum. And do you think that's taking over the radio spectrum and can threaten facilities like the NGVLA or other facilities?
Yeah, so we spend a lot of time. We have a detailed collaboration with SpaceX, which is one of the companies that is doing this. I mean, the satellite constellations are all broadcasting in the bands that they are legally able to broadcast in. And so, you know, for many years, all of the radio telescopes on Earth are, you know, we are always dealing with other sorts of transmissions and so on. So these transmissions that are coming from the sky are quite significant, but they are focused in particular parts of the radio spectrum and so on. So while it is the case that there, you know, some things that we want to do are going to be harder, there's still plenty of radio spectrum available to the radio astronomy community. And, you know, we are working with those companies to find ways that we both can move forward. I think it's very important that we continue to protect the scientific spectrum and to do the best job that we can to build instruments that can survive that. But at the same time, you know, I also think that global internet access is an incredibly important thing for society. And so just saying no is not an appropriate answer. So we need to find ways to work together. And I'm pretty confident that we can find ways to work together so that we both achieve our goals.
Thank you.
Right. There has been even talks, I remember, of actually dividing every second of time using the first half for communications and the second half for radio astronomy. It sounds crazy, but apparently it can be made.
It can be done. And this summer and later this year, we are doing tests with SpaceX to start to look at those sorts of capabilities and what would be required and so on. So it sounds crazy, but it can be done, as I said.
Right.
And we're going to do it.
Yes. I have another question in here, you know, that is related to how should a young person train herself or himself? Because in here, Susana is a theoretician.
require all those different types of observations and just not get too stuck into one of these things. Don't choose a problem that only requires radio data. Have a broad experience. Learn how to use radio telescopes and optical telescopes and satellites and archives and surveys and so on. So I think it's the secret, if there is a secret, is choosing a right project that really touches all of these things and makes you a very capable, broad person that can then go on into that science topic, or you can actually go into any one of these areas in the instrumental side. So that would be the advice I would give my kids, yes.
Right.
Can I ask something? It has to do with the NGVLA. Yeah, I saw, Tony, that you showed that the NGVLA could also make use of other antennas, not only in the north of Mexico, but throughout the territory. I mean, southern antennas. I mean, is that a possibility?
Yeah. So the way that our radio telescope works is that we need multiple antennas, and there are mathematical models for how those antennas should be laid out to produce the best image of the sky. But at the end of the day, having more antennas is good, is better. And so, if you decide to add more antennas, the sensitivity and the improvement in the radio image that you get basically goes up as the square of the number of the antennas. It's not linear, it's better than that. And so this idea that by adding a few more antennas throughout Mexico, not only does it bring, a lot of collecting area and improved imaging capability to NGVLA overall, it also means that you can get different parts of the country involved in the scientific endeavor. You can, work with different regions and so on. So, the other benefits of NGVLA, some of this science training, training students, getting high school kids interested in science and so on, that doesn't have to be focused in one area in the north. If you've got more of this capability, you can actually get a lot of places engaged. And that's very much what we're doing with the VLA. The current VLA is very New Mexico, and we do some great work there. But NGVLA will be Texas and Arizona and Mexico and possibly some other states as well. So it's, more antennas is good, and it creates better science, but it also spreads the wealth. It gets everyone involved in the science and the engineering and the education part. And that's part of it that we're very excited about.
That's wonderful.
One problem that I guess we're facing everywhere is that science has developed in such a way that bigger and bigger groups are doing the science. In the first half of the past century, astronomers published alone, Herbig and all those bigs, they just publish alone. And then 2 or 3 people, and then 5, and then 20. And now we're talking of hundreds or even thousands of people. Have you been in charge of so many personnel? Have you come with a good idea as to how to evaluate these people? It is very hard.
Yeah, it is very hard. We don't have. Well, I guess that's not true. We have some examples in astronomy like this now where it's 400 people on a paper and it's hard to kind of figure out who did what and so on. But radio astronomy and optical astronomy is not entirely like that now. Well, that problem is coming. But we don't have the same problem that the particle physicists have, for example, where it's 1,000 people on a paper or something like that. Well, that's an interesting difference, for example, between NGVLA and the SKA. I mean, the SKA is a survey instrument, and so you will have big collaborations doing fantastic science that way. We want to run the NGVLA kind of the way that we run the VLA. So Luis Rodriguez and 2 of his students can write a proposal to get time on the NGVLA, and they are focused on an object, and they are focused on a particular problem and so on. And I think I agree with you that, there are science problems that require thousands of people, the Large Hadron Collider. And so inevitably there's going to be that huge, contribution of all of these people, and how you work out, how to hire people and who gets faculty positions and all that. That's very hard. But we don't have that problem in astronomy just yet. And I would actually say with the NGVLA, we are still what we call kind of object-oriented. We really want, the kind of the core to be a small group of researchers and their students, and they're working on a problem. Now, we will do surveys, and I bet you there'll be huge papers that come out of NGVLA and so on, but that's not the bread and butter part. That's not the main part. The main part is the type of science that we already do on the VLA. And so, as we look forward in the next decade, we've got things like the Rubin Observatory and Advanced LIGO and JWST. And these are also all telescopes that are kind of focused on objects and, limited samples and trying to really understand the nature of something. And so I think NGVLA fits very naturally into that in terms of, teams of a certain size. I completely agree with your initial question, Luis, is if you get a paper with 1,000 people on it, how do you work out who did what? It's very difficult. Yeah. So we're hoping not to go that way in general.
Right. NRAO has been great in that sense because indeed, as you said, it has allowed, the professor in a small university that has a couple of students to get some time and do his research without really having to be part of one of these consortia. That is another way of doing things. Both ways are valid, but it's great that there will still be the possibility for a small group to come with research. And of course, science will advance using both ways. Both ways. Yes.
This is actually a lovely thing that the National Science Foundation does, right? CEF offers these facilities like the VLA and the optical telescopes and so on. They make them available to the science community and people getting time on these instruments. It's based on the quality of the science proposal that they actually make, and I think it's an incredibly democratizing step by doing this, by making it just about the science and letting the small groups and large groups, letting everybody compete and get time on the instruments. It's a way of really making sure that science gets done at all of these levels rather than just at the big universities. And so that's actually one of the things I really like about NRAO and Open Skies Science is that it's a way to really get everybody involved at all levels in all countries. So that's kind of cool. I like that.
I also think that Mexico, the collaboration between the group of Luis Rodriguez and all his colleagues with the VLA is really an example of international collaboration. Mm-hmm. And I think Mexico has been benefited by the VLA, and I hope that it can contribute more to the NGVLA. Can I say something? I mean, usually we have some greetings from people in different parts of Mexico, and I don't know if I could just read them to you, no? Because they are very kind to say that they are here. So Luis, can I go ahead with this?
Please go ahead, yes.
So we have greetings from the Universidad Autónoma del Estado de Hidalgo, greetings from Tlalpan, greetings from Mérida, Yucatán, greetings from Colombia, greetings from the Escuela Superior de Ciencias de la Educación en Chilpancingo, Guerrero, greetings from Mexico City, from Irapuato, Guanajuato, from Culiacán, Sinaloa, from Papantla, Veracruz, from the Universidad Autónoma de Coahuila, from Puebla, from el Planetario Luis Enrique Erro, y from el Centro de Estudios Chimalhuacán. So I think it's nice that all these people are sending greetings to you.
Yes, we are very thankful to them for having listened to the presentations. And I'll ask Susana, would you like to add something? Or Tony, would you like to add something?
I just want to say thank you. We are very excited about NGVLA, and we are also very excited to continue this collaboration with our Mexican colleagues. And I really hope in the near future on science and technology and all of these areas we can continue to work together.
Yes, maybe I can take the opportunity to ask Tony about the 21 centimeter signs with the NGVLA. I know that the a square kilometer array is going to be devoted to 21 centimeters and lower frequencies. But how much improvement will the NGVLA have on these 21 centimeters that comes from the molecular clouds, from the envelopes of molecular clouds,
Sure.
from winds of stars?
Sure. So the SKA Phase 1, which is being built in South Africa and Australia, as you were saying. So this is an incredibly powerful instrument, particularly at lower frequencies. So when you look at the 21 centimeter capability of the SKA instrument, which is being built in South Africa to do 21 centimeters, and NGVLA, well, the NGVLA is more collecting area, but it's also in the Northern Hemisphere. And so, what you have with SKA and with NGVLA is you have that kind of global sky coverage that you might need to research different parts of that problem. So both instruments are very sensitive to 21 centimeter radiation. When you get to more redshifted H1, as you go down in frequency, that is very much the domain of the square kilometer array. They have incredible capabilities down there. And so in the early universe, when we look at distant redshifts, that is the place where the SKA will really do some amazing science looking at this. And then ultimately there's the epoch of reionization, where we're actually seeing neutral hydrogen in the universe for the first time. And that is absolutely a low frequency SKA problem. That's the type of observation they'll be doing in Australia. So, I think head to head in nearby galaxies on H1, I think NGVLA will win, but they're very comparable. But certainly as you start to move out to higher redshift in the universe, SKA will be an amazing instrument and unsurpassed in what they can do there. Yeah.
And compared to the deceased Arecibo?
Because Arecibo is a single dish telescope, so the comparison is difficult. If you actually look at the total amount of collecting area in Arecibo, well, it was in Arecibo. It's enormous, right? It's really a very big thing.
Okay.
I think NGVLA, let me think about this. I think NGVLA is a comparable collecting area to Arecibo, and it can do the imaging instantaneously. But that's kind of a different, it's sort of a difficult comparison. It's like comparing a zebra and a giraffe. They both are sort of the same thing, but they're not in some ways. And so their science goals are different, and they operate very differently. But yes, I mean that was a very sad thing in our community in the last months, is the loss of Arecibo, because it was such an incredible amount of collecting area and unsurpassed for the applications that it was very good at.
Now the reason I asked is because Arecibo detected the neutral winds from protostars, but it could not map the neutral wind, and VLA was able to map, but it was very difficult to map this emission of the neutral hydrogen coming from the winds of protostars.
It was difficult in sensitivity or in spectral?
I think in sensitivity.
Oh, okay.
Yeah.
Right. Yeah.
But so the NGVLA will be better, and
Fantastic.
we need a high resolution, and because everybody can see not everybody, all the instruments can see the ionized gas, but not the atomic gas, which is the 90% of the material. No?
Okay.
Mm-hmm.
Well, we're almost finished, but I have a question that I think is relevant from Isaac Triguedacro, who asked, what opportunities does the NGVLA create for graduate students in Mexico?
Right. So it depends on different timescales. So over the next 5 to 8 years, I think the opportunity for graduate students in Mexico would be to get involved in kind of the design and the construction of the instrument, in the sense that there's lots of engineering problems that need to be solved. There's software algorithms that need to be derived, and so on. So there's kind of that kind of fork in the road that you can imagine, right? In the next several years, a lot of the effort is about array construction and the fundamentals of radio astronomy and so on. On longer timescales, once we get back to science operations and all of that, the science will begin immediately. I mean, the types of projects that are listed in the science book for NGVLA will all become active, and people will do initial surveys and deeper surveys and that kind of thing. So I think that's the answer is a little different on two timescales. For the next several years, I think people that are interested in instrumentation and engineering and technology development and all of that, there are plenty of opportunities there. On longer timescales, there'll still be some of that, but it will also then start to think more about the multi-wavelength science and what the actual instrument can be done. So my specific recommendation is that, in Mexico, we are collaborating with our colleagues on the Zoom call here and others throughout Mexico. Right now, for example, we're about to advertise for a postdoc to work in Mexico to start helping define where some of those sites might actually be. So I think as the project continues and, there are more opportunities for engagement between the US and Mexico and NGVLA, there'll be other opportunities in the short term to get involved in NGVLA design and construction, and then eventually there'll be more engineering and science that people can get involved in.
Thank you very much. Well, if you don't have any more comments or questions, I think that we have to thank first our friends from the El Colegio Nacional and our friends from Washington that helped organize this, and of course to Susana and Tony for their excellent presentations. And we hope to have another meeting in the future with things already going on. Thank you very much. Thank you.
Thank you.
Thank you very much.
Esta semana en el Colegio Nacional, un radiotelescopio de nueva generación. El Tahuantinsuyo y el Virreinato del Perú. Poesía del barroco novohispano, fiesta y competencia. Los Estados Unidos y el nacimiento de la Edad de Oro de la crítica. Despacio que tengo prisa. La historia de una paleontóloga y Tlatolopus. La evolución de la autonomía universitaria. Del 14 al 19 de junio, el Colegio Nacional te invita.
Te quieres tatuar, te quieres perforar de este lado, delineado facial, te quieres tatuar. El lineado facial.
Esta semana en el Colegio Nacional, un radiotelescopio de nueva generación. El Tahuantinsuyo y el Virreinato del Perú. Poesía del barroco novohispano, fiesta y competencia. Los Estados Unidos y el nacimiento de la Edad de Oro de la crítica. Despacio que tengo prisa. La historia de una paleontóloga y Tlatolopus. La evolución de la autonomía universitaria. Del 14 al 19 de junio, el Colegio Nacional te invita.
De este lado, el lineado facial. pareja en promoción, te quieres tatuar, te quieres perforar de este lado. Delineado facial, te quieres perforar, te quieres tatuar, te quieres